So of course, across the periodic table, I think you can see that the numbers get larger. In the Linus-Pauling scale, fluorine has the largest electronegativity. And you can see that the lowest electronegativities occur for the metals. They have the least attraction for the shared pair of electrons. Electronegativity goes up across the periodic table and goes down the periodic table. In addition to being able to predict the trends, I think it's also important to look at those elements, nitrogen, oxygen, fluorine, chlorine, and realize that they have really high electronegativity values. These are the most electronegative elements in the periodic table. And kind of keeping that in mind will help you explain a number of things, especially when we get to looking at polar bonds. Let's look at developing an explanation. Again, I'm scaffolding this for you. If you're asked to explain the trend, this is the sort of explanation I'd like you to make. Across the periodic table, the first thing we look at is the nuclear charge. And of course, the nuclear charge indeed increases across the periodic table. This results in an increase in the force of attraction between the valence electrons and the nucleus. And then, of course, this also results in an increase in electronegativity. Because, of course, electronegativity is directly related to the force of attraction between the valence electrons and the nucleus. The valence electrons, of course, in this case, are being the shared pair of electrons. Now, down the periodic table, the distance between the valence electrons increases, and therefore, of course, the force of attraction goes down. And, of course, the electronegativity will go down because, again, the force of attraction for that shared pair will go down.